Hello, my name is Cheyenne Pointer, and I am going over genetic algorithms today. We had to run a simulation and a choice that we wanted to. I chose dog training because that's kind of what I want to, a subsection, a hobby of mine I want to get into. And so the first thing I'm going to start off with is I went with Claude and we created a virtual dog training simulation. And here we can see how that is working. And so I'm able to change the population size, the mutation rate, task, and how fast that the training is going. And then we also have the start evolution. And I'm on pause right now, but we're at generation 12, right? This is the best trainer we have, 41Z61M. And then it shows all the different parameters that we are testing. So the fitness, the reward threshold, the command frequency, patience, and consistency. And then if we go to the bottom, we can see all the results. This is kind of breaks down by time what everybody is doing, and we'll track what generation we're on, who won, and a quick summary. And then down here, this gives the overall results of the simulation. So consistency is everything, and less is more sometimes. So using less commands, and then teaching sit work best with moderate reward frequency and high consistency. So if we try running this again, we can do this with teach stay, and we'll start evolution. Hold on, I had to reset. Teach stay. Yeah, let's teach heal, and then start evolution. There we go. We can see down here. Ooh. That the simulation is going. And now, while we're waiting on those results. Here is whoa. Here is some of the other simulations that we went through. So I went through perplexity as well, and it came up with its own results. Hold on. Okay, so same different variables: reward threshold, command frequency, and fitness score, stabilization. And so rewards, this is the results that we got. Rewards: as soon as the behavior is detected, issues command at a moderate rate. And so all these different things that we're gathering from this simulation, I want to be able to use in the future and test how it does in the real world. I'm pretty sure it will be close to being similar. And then we went to ChatGPT, dog trainer again, same. So let's see. The winning style was basically perfectly consistent trainer, always reward the correct action. And they were able to teach the simulated dogs pretty well and pretty quickly. So that's super exciting. Copilot, chromosome design. So we have the rewards running our same variables, and then fitness. Okay, so, and this is how the workflow goes. So we're going to initialize the population, simulate the training, evaluate the fitness, see how the dog is actually doing, selection, choose the top performers, crossover, mix between trainers, and then mutation, tweaking the parameters, and do it over multiple generations. And so that's what all these are doing. Let's go back and see if we have enough generations. It's looking like that. Okay. Pause. All right, we're going to give it a minute to hopefully do reset. There we go. So perfect timing is key. the virtual breast trainer immediately after the dog succeeds. So this is something we're seeing multiple times in different types of AI. Heel training needs balance, consistency, and patience for the complex behavior. And after 4 generations, the AI developed a strategy with 143% effectiveness. That's amazing. This is also from ChatGPT, a chart that shows after how many generations how good the dog did. And so you can see, starting off they didn't know anything. After not too many generations, under five, around five, they're already at 0.9. That's pretty great. Okay. This was also discussing changing multi behavior tasks. So adding that instead of just one trick, but having two different actions with that one trick. And so it broke down everything and how that would change. Um, so give fewer but well-timed commands, use variable ratio, reward schedule, space things out to keep the dog motivated. And so all these are really great advice and a really cool simulation. Thank you.